So congratulations. We've finished the trigonometry portion of the course. From here on, what we'll be doing are going to be largely recycling and maybe some small extensions of topics from Algebra 2. So the things that we're going to be doing from here on out will largely be familiar, which is nice, right? So we're going to start today looking at Supplement A, sections 1 and 2. So in this Supplement A, we're largely going to be concerned with solving systems of equations. Specifically, I think we're looking only at systems of linear equations, if memory serves. So we're going to start out with systems of two linear equations. So that means that we have one linear equation like ax plus by equals c, and a second equation dx plus ey equals f, where any x and y that satisfies equation 1 also has to satisfy equation 2. So that's what we're saying, okay? So that's what we mean by a solution is going to be some xy that satisfies both equations. Well, one way we can kind of interpret that is to look at this algebraically, graphically, not algebraically. So let's say we have the system 4x plus y equals 8, and the system, or the equation 2x minus 3y equals 18. So if I want to do this graphically, what I'm going to do is I'm going to make a line for each of the two equations and try to find where the line intersects. So I'm going to take equation 1. And how many points do I need to graph a line? 2. So what I'm going to do is I'm going to rearrange my equation for my line so it's in slope-intercept form. So in this case, it's just going to involve subtracting 4x from both sides. And now I'm just going to make a little xy table. So maybe I pick 0, and when I plug 0 in for x, I get 8. And then maybe I'll pick 2. When I plug 2 in for x, I get 0. So there's the points I need to graph line 1. Everybody feel okay so far? This is like Algebra 1 algebra right now we're doing. Let's say that we pick, or for equation 2, I'm going to start by doing the same thing. I'm going to subtract 2x from both sides, and then divide by -3. Everybody okay with what I did there? Again, some Algebra 1 algebra here is all we're doing. Now I'm going to find 2 points on that line. So maybe I pick 0 and I get -6. And then maybe I pick, let's do 3. And that's going to give me -4. So now I'm going to go ahead and try to draw my graph. Actually, let's give myself a lot of space here. All right. So 0, 8, 1, 2, 3, 4, 5, 6. Not quite enough space. So 0, 8. Oops. Then I have 2, 0. And I'll draw my line here. Where's my mousey? There you are. Okay, that looks all right. Okay. And then we'll go, oh my goodness gracious, what did I do wrong here? What points was I supposed to graph? What points was I supposed to be graphing for the red line? What's it say in my table? Yeah, look at what I plotted though. I plotted 0, -8. Oh, Mr. Kulik. Ugh. 1, 2, 3, 4, 5, 6, 7, 8. There we go. Try that again, you bonehead. Look, guys, look at how easy it is to do a goober there. Yeah, well, you know, you would have, maybe eventually. All right, so 0, -6. 1, 2, 3, 4, 5, 6. And then 3, -4. 1, 2, 3, 1, 2, 3, 4. Okay. All right. And so where should my solution be? That's my solution, right? That intersection. Now, what are you noticing about that? Doesn't really look like it's a whole number, but like if I look up here, if I look a little closer, doesn't look like I really made it through the 0.20 there, does it? Maybe let's try redrawing our red line. That didn't look great. Let me grab my ruler again. Maybe try that one more time. Yeesh. Who gets a little carsick when the screen moves real fast like that? When you're looking at somebody else's screen, they start moving it real fast. Kind of makes me a little carsick sometimes. So now, if I take a closer look, what do we see now? What appears to be the solution? Looks like that same spot, 3, -4, right? Now, do we know that's the solution, or does it just look like it? Could it actually have been like 2.9 and -3.9? Maybe. Mr. Kulik, is there a way to check? There is. What we're going to do is we're going to see if that satisfies our system that we had that we're trying to do or trying to solve. Didn't land where I wanted it to. Okay. So for equation 1, I'll have 4 times 3 plus -4. And does that equal 8? What do you guys think? Yeah. Okay, good. But I'm not done because it has to satisfy both equations. How about that one? Does that work? Since it satisfies both equations, we know that's our solution, right? What's the downside of this method? Well, neatness counts, right? If I'm able to graph like infinitely neatly, then sure, I got it. But like I live in a real world where I actually have to draw these lines and stuff, and like if things aren't straight, if your tick marks aren't evenly spaced, if you're not using graph paper and a ruler, it's hard to get even an integer answer correct, right? And if this answer was something kooky, you know, like if it was negative, or if it was like 2 7/8, negative 3 1/8, good luck getting that to come, you know, like, yes, if I make like infinitely fine graph paper, I can get that, but like who has time for that, right? Like my graph paper have to go up by 8ths or something. And like, why would I even think to do that at the start? And then I have to regraph the whole thing when I realize like, oh, that's not exactly an integer, right? Like it's just kind of a hassle. In theory, lovely idea, right? In practical terms, if the answers aren't whole numbers, or even like something easy like a half, if they're fractional, or even worse, like irrational, ooh, boysy. Is everybody okay with that? You get the idea of like why this is maybe not the greatest. Now, you know what is really good at being like infinitely neat? Are machines. So we can do this problem on our calculator. So into my calculator, what I'm going to type in is going to be the version where I've gotten the y by itself. So if you have your graphing calculator with you and you'd like to follow along to see this process work in action, I invite you to take out your graphing calculator and follow along with me. If you'd like to borrow one of mine to follow along with, I have a couple sitting up here on my desk, and you're welcome to do so. So after turning my calculator on, I press the y equals button. That's in the upper left-hand top corner. Upper top, right? That makes sense, Mr. Kulik. You know what? Don't judge me, okay? So into y1, I'm going to type in this equation in red. Y equals, now the y's already there, so I'm just going to do negative 4x plus 8, right? The calculator already starts y equals. And then equation 2, I'm going to type in to the next line. So again, it already starts y equals, so I'm going to do 2/3 and then x minus 6. Everybody's okay? I don't know what this last time I graphed something is, so before I hit graph button, I'm going to press zoom and then select option 6 on my calculator, which is zoom standard. That's just going to reset your window to like the -10 to +10 range. Hi, Ellie. So my intersection is right there, right? Everybody see that? Now the calculator can find that point with like as much accuracy as it has decimal places. So to get the calculator to do that, I'm going to press second. That's the blue button. And then the trace command, which is right there up at the top home row. And all of these options in this calculate menu are things that are going to operate on the graph. Which of these commands sounds like the one that we want? Can anybody take a guess? Intersect. Yeah, so I'm going to go down to command 5 and pick the intersect command. Now the calculator is going to ask me 3 questions. So the first question it asks is first curve. So you see my cursor floating right here. It's just saying pick what 2 things you want me to find the intersection of, human. Well, I only have 2 equations in here, right? I didn't type in more than that. So guess what I can do? I'm going to press enter, and notice it toggled already down automatically to the second one. Just going to press enter again. It doesn't matter where you do that at, first curve, second curve. And then it asks for a guess. If we're dealing with linear equations, how many times can these intersect? At most once. So it doesn't matter where I pick for my guess. If I had lots of intersections, then I'd have to be careful to make sure I'm picking close to the one that I want. But for a situation like this where we just have straight lines, it doesn't even really matter. Just press enter again, and boom. Intersection is x equals 3, y equals -4. Dunzos. Isn't that pretty easy? Yeah, I thought so too. That's pretty nice. All right. Any questions on this process or how to do it on the calculator? Okay. We won't really ever use this process to solve anything because in practice it's kind of a hassle unless you're using your calculator. But gosh, do they have the snowblower out? Sure do. Jeepers creepers. All right. So let's think back. Now take a trip back to geometry. We have 2 straight lines, right? So one thing could happen is, like you can have one intersection, right? What else could happen with 2 straight lines? So they get one intersection, right? What else could happen? They could have no intersections. What's that going to look like? It looks like parallel lines. Great. And there's one other situation that can happen. You get one solution, you get 0 solutions. What else can happen? Infinitely many solutions. Yes. What does that look like? Yeah, where one line is just right on top of the other line. So IMS stands for infinitely many solutions. I use that abbreviation because that's a lot of letters to write down every time that happens. Everybody's okay there? Okay. So if my lines have different slopes, I'm always going to have one solution, right? If I have 0 solutions, if they're parallel, they must have equal slopes, right? And different y-intercepts. And if they're infinitely many, well, they have to have the same slope and the same y-intercept. Because they basically just have to be the exact same line, right? Does everybody feel okay on that idea? So ideally, if I'm doing this by hand and I'm rewriting these into slope-intercept equation, I'm going to know immediately just from looking at what I got whether it's going to be one solution, no solution, or infinitely many solutions, right? Okay. So like just as a quick example here. So it says solve by graphing and determine the number of solutions possible. So again, I'm just going to do this the same way that we had done before. So I'm going to take equation 1, write the equation for the line in slope-intercept form. And before I plot points, I'm going to do the same thing for equation 2, because now I know some of these solutions I don't even need to generate points to get, right? I just need to look at the equation, because if it's no solution or infinitely many solutions, then I don't have to worry about it. So I'm not going to plot any points yet. Because it might just be a waste of my time. So I subtract the 8x over, then I divide by 4. And what do I see? I see equal slopes and different y-intercepts. That tells me I have 0 solutions because the lines are parallel. What do you guys think on that? It's okay? No big deal, right? All right. On to section 2. We could do this whole chapter in a day, but I don't really think that's probably good for you guys. We might do 3 also. I have to kind of decide. We'll see how long this takes. All right. So we've just seen what to do with a system of 2, or a linear system of 2 equations, right? What happens if I have a linear system of inequalities? So remember, we said a solution is an x and y that satisfies each equation. So a solution to a system of inequalities will be an xy that satisfies each inequality, right? Now, in general, every system of inequalities is going to be either infinitely many solutions or no solution. But the infinitely many solutions doesn't mean like everything is an answer. It just means that we have infinitely many answers. So we'd like to be able to differentiate one infinitely many solution from the other. And the way we're going to do that is by doing it graphically. So what we're going to do is we're going to graph each of these inequalities separately and look at where the overlap is between the inequalities. So we're going to solve each inequality separately and then look at the overlap of their solutions. Everybody's okay with that idea? So just like before, I'm going to take my first inequality and try to rewrite that so it's in slope-intercept form. So I'll subtract the 3x over, and then I'll divide by -5. When I divide an inequality by a negative value, what do I have to remember? Yeah, the inequality changes direction. Everybody feel okay there? All right. And then we'll do kind of the same thing for this one. So I'll add the 12y over, or I'm sorry, 12x, and then divide by +7. Since I'm dividing by +7, I don't need to worry about flipping anything. Yes, if I multiplied by a negative, it would also flip. Absolutely. Is everybody okay with how I did that as my first step? Okay. So what I'm going to do next is I'm going to pretend that these are equals. instead of an inequality. And I'm going to find 2 points that lie on that line. So let's see. Oh, these all stinky options here. So I don't know. I'd do, I guess we'll be dumb and we'll do 0 and -2/5. And then, I'll just do 5 or something. So that'll be 15 minus 2, so 13/5. Or I could think about, we'll show you what we're going to do here in a second. But in general, I don't think that you get quite as many like stinky decimals like I'm going to get in this one. But this one, the precision is much less of a requirement. So it's not so bad. But yes, you can still graph this on the calculator. But it's just like less of a necessity. So again, we'll do the same thing. So I'll do 0 and 3/7. Yuck. And then, I don't know, 7. That's 85/7. What do I do with this last one, though, where it just says y equals 9/2? What do I plug? What do I pick for x's? There's no x in there. What do I do? Well, here's the thing. What does y equal? 9/2. It's always going to be 9/2, no matter what x you pick, right? Because y is just constantly 9/2. So I don't know. Let's just do that for something. Didn't matter, right? Because the y is just 9/2 no matter what x you pick. So you could have picked your favorite number. What's your favorite number? 15? 13. How about you? 55. Anybody else with a favorite number? 6.
21.
21. Mine is 42.
That's also good. I like 42. I like
It's the ultimate number.
42 is like a 5. Yeah.
Yes, 32 or 42 minutes.
No, 48. Yeah.
It's a what?
It's the color blue and it's like a Friday.
Yeah.
Oh, okay.
6 is like a Thursday purple.
There's a book called The Hitchhiker's Guide to the Galaxy, and in the book, like this, it's like it's a satire, like it's, you know, like it's an allegory about like how dysfunctional like British society is or whatever. But one of the little plot lines is that, you know, like this group of like super intelligent aliens has built a machine to try to answer the meaning of life. And the machine that they built, the answer it gives them is 42. Wow. So then they have to build a bigger machine to figure out what actually the question is that we should be asking this other machine. Which is that's why 42.
What does it come out to be?
They don't ever, it doesn't get solved because it turns out that the Earth was the bigger machine. And anyways, it's a wild book. All right, so I have 0, -2/5, and then I have 5, 1, 2, 3, 4, 5, and 2.6. All right. So now I'm going to go back and look at my inequality. So notice my inequality was a or equal to inequality. That means when I draw my line, it's going to be a solid line. Let's use the ruler. And because it's greater than, I'm going to be shading above it. Now I'm just going to draw an arrow to remind myself which way I'm supposed to be shading right now, but I'll finish my shading so I just have one spot shaded so it's not so like gets too busy for me. Is that okay with everybody? You vaguely remember doing this in Algebra 1? Maybe. Okay. Well, that happens. Then we got 0, 7, or 3/7, and then 7, comma, like 7 and 3/7 or something, or 12 and 3/7. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm already sick of this. I'm picking a different number here. 3, and then that's going to be 39/7. That's much better. That's just a little less than 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. So maybe I got something like that. Okay, notice this one is a strict greater than. So I'm going to be using a dashed line. And again, we're going to be shading above. And then our last one, we have 0 and 9/2, so 1, 2, 3, 4 and a half, and then 5, 1, 2, 3, 4, 5, and then 4 and a half. Again, this one was less or also greater than or equal to. Yes, sir. Because the inequality was greater than or equal to, or greater than. Okay. There we go. So this was another or equal to, so it's going to be a solid line again. And again, we're shading above. So let's look at this. We are going to be above this line, right? And then we also have to be above the blue line. That's okay. We also have to be above the red line, but we are above the red line like everywhere there still, right? So that would be like what my solution would look like.
Don't you have to be below the yellow line?
Well, it's y is greater than,
Oh, that's okay.
so it should be above.
Yeah.
What do you guys think? It's not bad, right? So,
Graph those on the calculator.
yeah, so let's show you how that looks like on your calculator. So I'm going to plot these as their equals to. So I'm going to do 3/5 x minus 2/5. Oops, forgot the x. And then notice this one is greater than. So I'm going to move my cursor over here. You see how it's on that little slash? That's telling us the graphing option. So right now it's just plotting it to be a line. That's a thick line. I don't want that. That's shading above. That's what I want it to do because it's a greater than or equal to. And then the next one should be 12x or 12 over 7 and then x plus 3 over 7. And again, that should be shaded above, so I'm going to do the same thing. And the last one was y equals 9 over 2. And that one was supposed to be shaded above. So I'll do that. And if I hit graph, there's the first line we're shading above. There's my second line we're shading above. And there's my third line we're shading above. So the overlap of those three shadings was like this section right up here. Does that make sense? Pretty cool that the calculator can handle that too. All right.
Our answer should be the graph.
Is the picture, yes.
Right, so just have to draw it.
So you do have to draw the picture there because the shaded region is literally your answer. So for example, if I pick, the point here, that's a solution. It'll satisfy all the equations, right? Or if I picked a point here, that's a solution. It'll satisfy all the inequalities. If I pick a point here, though, that's not a solution because it's on the dashed line. That won't satisfy all of them. But if I pick a point there, that is a solution because it's on a solid line. That'll satisfy all of our inequalities as well. So like there's infinitely many you can pick, but like the picture kind of marcates out like what is a solution and what it, like where you can choose from. Now there's infinitely many choices in there, but not every choice is a solution, right? That feel okay? What do you guys think? Is this pretty easy? You're super happy with what we've done today so far? Extremely. Okay.
Yesterday I thought it was Thursday night. And then I realized it was Monday.
That's a long. It's gonna make for a long week.
Thursday. You're so right. I didn't know color.
Yeah. Yes, but you're gonna have to do an example problem when you get back. You're gonna have to do an example problem with me when you get back. Really?
Do one next time. Come on, get up there. Come on, girl, you can do it.
You can do it.
What world can I say? Just try. You never know unless you try.
Yeah.
Okay, so I'm not trying to think of that. Sid, I'll do it. Can Mora help me out with it?
Can Mora help you out with it?
See, I technically don't even count as helping. Okay, wait, I got it. I'll help. I'll try.
I know, that's what I'm saying. I do this right. Like, that's always been on
I hate it. And no
All right, Sid, tell me what to do.
Is it worth it? No, it's go up there. See, just go up there and do it.
Great, so let's take the first one. And what do I need to do to move that into slope-intercept form?
Do yourself.
When we say slope-intercept form, what do we mean? Get the y by itself. So do some algebra 1 algebra to get that y by itself. You're doing minus 3?
No, I lied. Do minus 2.
Minus what?
Minus 2.
Minus 2?
Sydney, I'm helping you. That's not right.
This is, you can do this?
Sydney, it's 2x.
Do minus 2x.
Okay, that seems better. Again, how, yeah.
I feel like I have to help you.
6 is Y.
Yeah.
And,
Okay, so that one's good. Let's do the next one.
The other one? I thought it was done now.
It is done. Good.
That was one problem.
You haven't done even finished a problem yet.
It's like in the same form, so don't be just like.
Okay, so now we have to do what? Okay, what do I need to do to graph the first equation? Or inequality, I should say. What? What's that? Well, she said we have to graph these now, and I asked her what she needs to do to graph them. Great, a table. Okay. What now? You gotta do the whole thing.
Like a 1, like it's not.
Oh my god, okay, so like 1, like 0.
What's when I plug a 1 in? What do I get? We get negative 2/3 plus 6. What's that?
Wait, no,
What do you need to do? No.
What? What are you saying right now?
because you won't use them. Oh, you add them. So it's
You don't need a calculator.
I can't think right now.
You got this, Dad. Come on.
16 over 3.
Thank you, Sydney, aka Reese.
Oh my gosh, yeah.
Now we gotta.
Well, let's get the other. Let's get the other table first.
Oh my gosh.
She doesn't give us any time in class. We got time today. She like doesn't give my class. She doesn't give us any time.
Shh. I have a hard time hearing Sydney mumbling to herself.
10 over 3.
Okay, that seems reasonable. Now what do we do?
Grab it.
Okay.
I feel like since you're solving, she could do it yourself.
Okay. So which one are we plotting first? The red one or the blue one? The blue one first. Okay. 1, 2, 3, 4.
Honestly, I would.
And then 1, 2, 3 and a third is probably like that. Okay. How am I going to draw the line?
It's gonna be like that.
Do I use a solid or dashed is what I'm asking. Which one?
We know it's solid.
Why?
Because it's an inequality. Or
Uh,
not inequality, I meant it's like an equal to or.
there you go. An or equal to inequality.
Yeah.
And then which way should I be shading?
Below it. Above it.
Why above? Yep, so you want the y's bigger than the one on the line. All right, let's do the red one now. Same idea, right? So 0. Oh my goodness, Mr. Kulik, that's supposed to be a 2. Six divided by 3 is 2.
Yeah, I know.
Nope. I fixed it for you. Calm down. Okay. And then how am I drawing this line? Solid or dashed? Ah. Okay. And then are we doing above or below? Okay. So what do we say here? Why is there no solution?
You're shaded at different ends.
Because there's no overlap, right?
Parallel.
Well, parallel lines could still give us a solution, right? If the blue line was below and the red line was above, it'd be the spot in between them. There'd be the solution. Just because they're parallel doesn't mean it's going to be no solution here, right? Because they're inequalities and not lines, right? Okay, Sydney. Now you can go. Probably not based on her laugh.
I would have if you told me.
I wouldn't take it anyway. She'll probably spit in it on the way back.
Oh, really?
Okay. What'd you guys think on that one? Not bad, right? We can do this. Can totally do this. Great. All right, one more then.
One more. No, it was actually kind of hard.
Let's talk about. You blew it when you guys were like, "Oh yeah, this is easy."
Is this the next lesson?
Yep.
Beautiful.
All right. So
Next lesson.
what we saw in section 1 was that graphical method we presented to solve a system of equations was El Stinko, because it's kind of time consuming and neatness really counts. And even if you're being really neat, if the answer is like a kooky decimal, good luck with that. We really want a better method where the type of answer you're getting becomes less of a hindrance and where neatness isn't really a factor. We'd like an algebraic method that I don't have to rely on a graph. Everybody cool with that plan? Substitution and elimination are the two methods that we were going to look at. So, to do the substitution method, first thing we want to do is to solve one of the two equations so that we have isolated a variable. Now, if I look at equation 1 and equation 2, which equation would I want to use and which variable from that equation would I want to isolate?
Equation 2 isolate.
Excellent. Why did you choose to do that? Because the coefficient of x is already 1, which means we don't have to divide and we don't make any fractions. Is it okay to get fractions? Sure, and sometimes it'll be unavoidable. But do you like dealing with fractions? No. So let's use our heads and try to choose not to use fractions if it's possible in the problem, which is what Luca is suggesting. Everybody's okay with that? Next, using this new equation, we're going to substitute in to the other equation for the variable we just solved for. So we're going to have 2, and then from our substitution, 3 minus 3y plus 5y equals -5. Notice this equation has only one kind of variable in it now. It just has y's. Everybody see that? Just y's? So now we can just solve this for y. So I combine like terms, I get negative y. I subtract the 6 over, and then divide by negative 1, and I get y equals 11.
Wait, how do you get negative?
I combined negative 6y and positive 5y. That's okay. Everybody's good? What do I do now that I have I have half of my solution, right? I have the y, still need the x.
Plug in the answer.
Yep. And I'm going to plug it in here because the x is already by itself, so that like saves me just one little bitty bit of work, but I'll take that little bitty bit. What do you guys think? NBD, right? Remember doing this vaguely?
Yeah.
I think you do it in geometry also, right? Maybe do this a little bit in geometry. You did a little bit in algebra 1. You do it in algebra 2. Should be pretty good at it by now. What if we wanted to do elimination? Do you guys remember how elimination works?
You get two of the coefficients to be equal, and then the signs to be plus and minus.
Pretty close. Yeah, so the idea here is that we're going to pick a variable to eliminate from both of the two equations. In order to do that, we're going to want to make the coefficients of that variable opposite, and then we're just going to add the two equations together. So if I look at my two equations, would I want to eliminate x or y? I would eliminate the x because it's going to be easier for me to make 3 and 6 have opposite coefficients than it would be for negative 7 and negative 8 to become opposite coefficients. So to eliminate the x, what coefficient am I looking to make? Negative 6 in equation 1 and positive 6 in equation 2. What do I need to multiply equation 1 by to turn that 3x into a negative 6x? Negative 2. And then we're just going to add down. And we're left with one equation, one variable. I can solve for y now, right? That's pretty easy. How do I solve for y? Divide by 6. There's half of my solution, right? There's the y. To get the x, what do I need to do? Yeah, I can take that and plug it into any place where there's a y. Doesn't really matter. For the sake of argument, let's plug it into the first equation. So 3x plus 14 is equal to 10. And I subtract 14 from both sides. And then divide by negative 3. I'm sorry, divide by 3. And so my solution is negative 4/3, comma, negative 2. Now, anytime you do one of these solvings, are these checkable? Yes, right? All we need to do is take our answer here and make sure it satisfies both equations at the beginning, right? So if you get a funky answer, you're like, ooh, is that fraction right? You can always go back and check real quick. Just takes a second. I promise you this one is. How do you guys feel? Pretty okay, I hope, right? Is this go time?
Yeah.
I think this is a good place to stop. Yeah, this is like, should be real familiar.
I just forgot it.
But you remember more of it now, right?
Yeah.
So you guys should be able to do up to 18. I think I assigned 1 through 4 already, but we went and did it again. Yeah, most of pre-calc that we're going to do is just going to be like a recycle and extension of some of these Algebra 2 topics.
So is that last string, that was the last chapter, that was a string?
Yes.
Oh.
I'm surprised you said I had 10.
So for Sunday, this will be part of your problem set. I think we already assigned 1 through 4, right? Some of us have done it, some of us haven't. I saw it in a couple of people's OneNotes already when I was checking homework. I did on the snow day or something. Whatever. Either way, if you've done it already, then you're fine. If you didn't, it doesn't take much time or effort. Everybody cool? Okay. I'm going to get out of your way. You still got like 20 minutes. I would get cranking here as you can knock out a big chunk of this.